All right. So, good afternoon, morning, evening to everyone, depending on where you are. As Erica said, my name is Danielle Carpenter, and I am the Satellite Technical Lead of the Remote Sensing Branch at the Naval Oceanographic Office, which is located at Stennis Space Center, Mississippi. And I am here today to give you an expanded briefing of the poster that we had at GHRSST 24, which is on the Naval Oceanographic Office Sea Surface Temperature Processing and Products. The team consists of myself, Valinda Kirkland, Michelle Little, and Jessica Schroeder from NAVOCEANO. We also recently added Omar Chiarte to the team here. We also have Charlie Barron, Jackie May, and Robert Hilber from the Naval Research Lab, and finally Jean-Francois Cayula from Peraton, who is also at NRL, rounding out the team here. So the agenda for today's talk, I will give the background into the MCSST project that's done here at NAVOCEANO, the multi-channel processing that we do, and from what satellites and sensors, show a general statistical analysis of how things look right now with our processing, who we deliver the process data to, a review of a special EWSG topic, go over our GHRSST contributions, and wrap up the talk with what future satellites and sensors we have our eye on before opening up the virtual floor to questions. Just to give a little background, shown here is our composite K10 image of the globe from the beginning of the month last month. So NAVOCEANO is a National Core Processing Center for the operational production of multi-channel sea surface temperatures, or MCSST for short. The project was established in 1993 via a Memorandum of Agreement on the shared processing of satellite data between the National Oceanic and Atmospheric Administration, the United States Navy, and the United States Air Force. This memorandum includes the policy, management structure, and areas of cooperation for the shared processing program. And these agencies share environmental satellite processing responsibilities as well as exchange of unclassified environmental satellite data products. This agreement was actually taken over by the Subcommittee for Operational Processing Centers, or SCOPSI, in 2008. Regarding the data requirements for processing here, the SST data, when acquired by NAVOCEANO, must be less than 3 hours old from the time of observation by the satellite on, or by the sensor on the satellite. Quality checks of the data are done daily, and statistics are calculated weekly as a form of monitoring. And lastly, the 10-kilometer gridded SST fields are updated daily with the latest satellite SST observations, as well as with climatology for the sparser data areas. These images, such as the one shown in the slide before this, and you'll see some more throughout my presentation, are used for regional support of anti-submarine warfare tactical forecasting. They are also uploaded to the Commander for Naval Meteorology and Oceanography Command, or CNMOC, web portal. They are sent out to the Navy fleet worldwide and are lastly distributed to any other customers who require any kind of gridded product. Seen below is our GHRSST JAXA AMSR 2 daily SST image from the beginning of the month last month. For MCSST processing, NAVOCEANO uses around 550 gigabytes of data per day in a variety of formats, which yields about 73 gigabytes of output data per day. The differences in sizes between the two is due to not processing data that contains cloud coverage, as well as data being removed via other quality control checks. We do have the ability to output data in a variety of different formats based on customer needs. Overall, 306 million unique observations are processed each day from 14 different satellite sensors, with a maximum turnaround time of 3 hours from receipt of the data to customer delivery. The processing software is predominantly written by the team at NRL, with the team at NAVOCEANO writing additional scripts for moving data around the systems as well as archiving. It is written in Fortran, C, Python, and Shell. And we use 2 REL system nodes for processing in a 24/7, 365 real-time environment. One system is used as primary and the other is used as backup. And we also have the capability to farm out to additional systems if needed. The data retrievals, which is from both polar orbiting and geostationary satellites, do go through extensive screening to ensure pixels are cloud-free. And once processed, they are ingested into the Navy atmospheric and oceanic models. Lastly, quality assurance and quality control checks and statistics are performed to ensure data accuracy, that we have the proper data coverage, and that the data meets the latency requirement. As mentioned, we are processing data from 14 different satellites as of today to ensure maximum coverage across the globe. We use AVHR, GAC, and FRAC data from both METOPS B and C. We use VIIRS data from NPP, NOAA 20, and NOAA 21. GRIST SLISTER data from Sentinels 3A and B. GRIST AMSR 2 data from GCOM W1. Imager data from the old GOES 15, now EWSG2. ABI data from GOES East and West, AHI data from Himawari 9, and GRIST Severi data from MSGs 2 and 3. An example of our daily K10 image is shown here for the Norwegian Sea area at the beginning of the month, last month. For the SST retrievals to be used in processing, they must have a root mean square error of less than 7.7 degrees C and a bias of plus or minus 0.2 degrees C when matched with global drifting buoy SSTs. And shown here are the last 2 years of RMS errors and biases, with the global satellites on the left-hand side and the regional satellites on the right. We use these statistics to guide us when regression equations for the satellites need to be changed, which uses the same database as these statistics. Of note, for the regional graphics on the right, EWSG1 ceased operations in November of 2023, and the replacement of EWSG2 has not quite been fully added into the processing just yet, so there is no statistical data for EWSG2 presented here right now. We have a variety of customers, domestic customers, who receive NAVOCEANO's processed MCSST data, and they consist of other Department of Defense and Department of Commerce entities who are both operational and research in nature. JPL PODAC hosts the GRIST data for us, and GODAY is also an important partner. We also have a few international customers as well in Australia, Canada, and Brazil who receive our data routinely. The image on the right is our K10 product for the Antarctic region at the beginning of the month, last month. Excuse me. EWSG1, which was the old GOES 13 satellite, was positioned over the northern Indian Ocean to provide SST data in that area. And in NAVOCEANO's MCSST processing, the nighttime data would be complete, but the daytime data was consistently masked to avoid erroneous SST data, which appeared as a circular hole in the area. And we determined that this problem was occurring due to GOES 13, 14, and 15, all missing the 12 micron channel and relying instead on the 4 and 11 micron channels for processing. And both of those channels are strongly affected by solar radiation. So the upper left image shows the hole created in the daytime processing, and the lower left image shows the nighttime processing. Once EWSG2, again, which is the old GOES 15, comes into the processing, the issue is going to continue to occur. And just wanted to point out this example as one of the hurdles that we face when processing real-time data for real-time operations in some areas. So for GRIST, which is why we're all here today, NAVOCEANO is, as I mentioned, a regional data assembly center for the group, and we provide a level 4 GDS 2.0 global K10 combined product to customers, as well as L2P GDS 2.0 products via the PODAC from the AVHRR GAC Global 4-kilometer data from METOPS B and C, the VIIRS Global 750-meter data from SNPP, and the IO 8-kilometer data from the EWSG satellites. NOAA 20 and NOAA 21 VIIRS is available if anyone would like to start receiving it, and the EWSG2 data delivery will be spun up soon to replace EWSG1. The GRIS products that we receive from ESA via JPL and STAR, as well as from JAXA, are the Severi L3C data from MSGs 2 and 3, the AMSR NRT data from GCOM W1, and the SLISTER L2P data from Sentinels 3A and B. Just wanted to mention all of this to show appreciation to all the partners that we work with and for all of the data that we do receive via this group. So thank you all so much. To wrap up the presentation, we have our eye on a fair amount of satellites and sensors for future MCSST processing, which is shown here next to a K10 of the Northwest Pacific area from the end of the month, last month. One note regarding the EWSP satellites, which are projected to be the old NOAA 18 and 19 satellites. Due to the upcoming orbit shift, processing on those satellites may only be primarily nighttime data. Daytime data in the polar regions would only be available during their prospective summer times. So the availability of those upcoming satellites are not necessarily going to be as good as the others that we would be receiving and processing. So that was all I had. So I can now take any questions that anyone may have at this time. Thank you all so much for listening.